In this example, we're going to write an equation of the tangent line to the graph of the function at the given value of x. So to write any tangent line, we need two pieces of information, a point and a slope. So any point that we use will have the x value and then whatever the y value is for that associated value of x. So we'll plug it into the function. Any slope that we use needs to be the derivative value once we plug x in. All right, so we have our work cut out for us. We need to find g of ln of 16, and then we need to find g prime of ln of 16. So let's go ahead first and find g of ln of 16. So it's going to be the square root of the ln of 16 minus 1/4 e to the power of ln of 16. Okay. Well, we could leave the square root as the square root of ln 16, but I kind of know that 16 is a power of 2, so it could be written as ln of 2 to the 4th, which then that 4 would come out front and be the square root of 4 times the ln of 2. And then this 4, the square root of 4 is 2, could come out and we could say 2 times the square root of ln 2. I don't know that that's really simplifying it or making it look any better, but you could say the square root of ln 16 is 2 times the square root of ln 2. As far as the other part of this, e and the natural log here are inverses of one another, so these could cancel, and what you're doing is taking 1/4 of 16, which is 4. So we could have now this for our y value, and that's what we get when we plugged in the ln of 16 into our function. All right, well, let's go ahead and find the slope now, but to find the slope, we first need to find the derivative of our function. So we need to take the derivative of each piece here. So the derivative of the square root of x is 1/2 times the square root of x. And then the derivative of 1/4 e to the x is just 1/4 e to the x. So now let's go ahead and plug the ln of 16 into our derivative. So it's 1/2 times the square root of ln of 16 minus 1/4 times e to the ln of 16. Well, you'll see a lot of similarities between this value and our previous value, because the square root of the ln of 16 could be written as 2 times the square root of ln 2, and then 1/4 of e to the ln 16 is still going to be the minus 4 here. So we could say 1/4 times the square root of ln 2 minus 4, and this will be our slope. Okay, so we know that we needed two pieces of information, the point and the slope, and in order to write it in point-slope form. And we have all that information. So remember, point-slope form is y minus our y value equals the slope times the quantity x minus the x value. So y minus, and then our y value, which is this guy right here. So 2 times the square root of ln 2 minus 4 equals our slope, which was 1/4 times the square root of ln 2 minus 4, and then times x minus our x value. See if we can squeeze it all in there. There we go. And of course we could simplify this a little. We could run that negative through there, and we could have y minus 2 times the square root of ln 2 plus 4 equals, and there's probably no sense in getting common denominators there, so we can probably just leave that alone, and then x minus the ln of 16. So here would be the equation of the tangent line given this initial function and the x value of ln of 16.